Lesson 16 is about using what's called Cramer's rule today. In lesson 15, we solved linear system of equations by graphing them. Graphing has problems though because first of all, none of us like to graph. Second, our graphs can be off by just a little bit, and then you can have some problems with trying to figure out what your answer is. Or maybe your line isn't perfectly straight, or maybe your lines intersect inside a box so you can't even tell what the answer is. Because of that, it is not a great way to solve these problems. One way to solve a problem, though, is by using what's called Cramer's rule. A Cramer's rule is just a method for solving these types of equations using determinants. Alright, the system of equations that I have here, I have a whole bunch of variables in here. It is just to show where everything goes. When we solve for x, we've got two parts here. We've got a determinant on the top and on the bottom. The bottom is the easiest to figure out. Okay, since we're solving for x, this is our x column and that's our y column. So our coefficients in front of x are going to go in that column. The coefficients for y are going to go in the y column. Alright, for the top, what we have to do though is because we're solving for x, our y is going to stay exactly the same. It's BD for both of them. But because we're solving for x, what are we going to put in for that column? We're going to put the answer column in for x on the top. For y, it's the same process. Okay, the bottom is exactly the same, you see. Alright, our AC is here, so that's the x column. Our y column is there, so that just goes in there. Since we're solving for y now, our answer column is going to go in for y. Our x stays the same. Alright, so how do we do this in a problem? There's our system of equations. How do we solve this? Well, our first step is you have to have x and y on the same side. You have to have it set equal to a number. So, it cannot be in slope-intercept form. It has to be x and y on the same side. So, then you decide, well, I'm going to solve for x. And remember, that's a determinant over a determinant. Okay, let's fill in the bottom first, because what we're doing for the bottom is we're just going to use our coefficients here. Remember, this is the x column, that's the y column. For x, it's 1 and 1. For y, it's 1 and 2. Alright, the top a little bit more complicated. Remember, we're solving for x, so since we're solving for x, our answer column is going to go into the x column. Our y column stays the same. And then we just do the determinant from there. So 2 minus 4. Remember, it's down minus up. 2 minus 4. And then 2 minus 1. Simplify this down. Negative 2 over 1. X has to equal negative 2. Alright, from there you have two options. We can always do Cramer's rule again. So let's do that first. Alright, so we set that up again. Remember, the bottom's the same. X column, y column. So 1, 1, 1, 2. We're solving for y. So the answer column goes in for y. We've got 1 and 4. The x column stays the same. So from here we multiply this out. 4 minus 1 over 2 minus 1. 4 over 2, y has to equal 2. Alright, and what you can do for this is you can actually plug this ordered pair back in to see if it works. And it does not. Because if we were to plug in negative 2 and 2, negative 2 plus 2 is 0. It's supposed to equal 1. So where did I mess up here? Well, where I messed up is right here, because 4 minus 1 is not 4. It is 3. And then 2 minus 1 is not 2. It is 1. That is the importance of checking. I made that mistake completely on accident, but that does show why you should check these. So your answer is not -2, -2. It is -2, 3. So now if we check it, this should work. -2 plus 3 is 1. -2 plus 6 is 4. So that does work out there. The other way to solve this a little bit quicker is once you find that x equals -2 here, we can always just plug that back in to solve for y. -2 plus y equals 1. Add the 2 over. Well, y has to equal 3 also. Now, could you make mistakes there? Sure. Alright, then what you have to do is you have to check your answer with the other equation. -2 plus 6 does equal 4, so that tells us that we are correct here. Alright, next problem. Solving for x. Draw out the determinant. X column, y column, so 2, 1, 4, 2. We're solving for x, so our answer column goes in for x. Our y stays the same. So 12 times 2 is 24, minus -8 over 4 minus 4. Well, our top we get 32. Our bottom we get a 0. That is a problem there. We cannot take 32 divided by 0, so what is going on here? We gotta figure it out. Well, let's see if we solve for y if we get something different here. Alright, so bottom, 2, 1, 4, 2. Okay, we're solving for y, so the answer column goes in for y. The x stays the same. Solve this, -4 minus 12 over 4 minus 4. -16 equals 0. So what the heck does that mean? Well, if we were to put these in slope-intercept form, let's try that really quick. So we've got 4y equals -2x plus 12, and then we've got to divide by 4. Y equals -1/2 x plus 3. So that's our first one. Then what we need to do is we need to solve for y here. And then I've got -x minus 2. Divide by 2 here. Y equals -1/2 x minus 1. If you look, our slopes are the same, so that means these lines are parallel. But our y-intercepts are different. So are we going to get an answer here? No. Our answer is going to be no solution. How we tell that from Cramer's rule is we have 32 divided by 0 and -16 divided by 0. If you get a number other than 0 divided by 0, then that will be no solution. Over here, we're going to have another case where if we solve for x here, we end up with, remember, x column, y column. So 2, 6, 1, 3, and then solving for x, 6, 18, 1, and 3. Do the determinant, 18 minus 18, and 6 minus 6. We end up with 0 over 0. You would get the exact same thing for y. When you get that, that means these two lines are the same line. So then, what is our solution? Well, we don't know, but we know that it is an infinite amount of solutions. All right, any questions on Cramer's rule? Please let me know.